Hey guys, this is Fraser from Links by Tutoring, and today we're going to be looking at a slightly longer question. This is an 8-mark paper 1 binomial/sequence question, so it uses both of the topics. You have to sort of combine your knowledge to be able to answer this question. That's why I like it. So let's give it a go. Let's get straight into it. So the first part's not too bad. It's telling us to look at the expansion of 1 plus x to the n in ascending powers of x, where x is greater than or equal to 3. So that's important. I'm just going to highlight that. Keep that in mind. So we don't know what n is, so we have to do this in terms of n. So 1 plus x to the n, we know there's always going to be n c0 of 1 to the, let's go n x to the 0 plus n c1, 1, n minus 1, x to the 1. And right now I'm going to pause. I'm going to ask you guys, what is 1 raised to any power n? That's just 1, right? No matter what you raise 1 to, you always get 1. So that means we can actually just forget about the 1. So we can just get rid of that because we know it's there. So actually, it's just nc0 of x to the 0 plus nc1 of x to the 1, nc2 of x to the 2. Oh, sorry, what am I saying? Yeah, that's correct. nc2 x to the 2, and it says first 4, so nc3 x to the 3. We can simplify this, so nc0, that's just how many ways you can pick 0 from n, that's just one way, and x to the 0 is just 1, so it's 1, plus how many ways can you pick 1 from n objects? That's just n, right? Because you can pick each one once and there's n of them, so that's nx, plus, and then these ones we're just for now going to leave as nc2 x squared plus nc3 x cubed. So that's the first part, that's part A. So, second part, or the first part of the second part, tells us that the coefficients of the second, third, and fourth, so second, third, and fourth, are consecutive terms of an arithmetic sequence. So now we have to show that this equation is true. So what does it mean if they're consecutive terms in an arithmetic sequence? That means that the next term minus the previous term is equal to the common difference, right? That means that the nc2 of x squared minus nx, which is the previous term, is equal to nc3 of x cubed minus nc2 x squared, right? Because the formula reminded that u of n is, or u of n plus 1 is u of n plus d, right? So that means u of n plus 1 minus u of n equals d. So that means that they're equal, so now we can work with this. So now we have to use the formula. It's in your formula booklet. nc2 is the same as n factorial over 2 factorial n minus 2 factorial x squared minus nx is equal to n factorial over 3 factorial n minus 3 factorial, oh, missed a bracket there, minus n factorial, oh sorry, a little bit clumsy, x cubed, minus n factorial over 2 factorial n minus 2 factorial x squared. So first of all, we'll notice that this term and this term are the same, so we might as well just add one of each to both sides. That means we're going to get 2 n factorial over 2 factorial n minus 2 factorial of x squared, and then we might as well bring the nx to the other side so everything's positive, n factorial over 3 factorial n minus 3 factorial x cubed plus nx. So I'm just going to use red here to show we can cancel out. So these two are going to cancel out because 2 factorial is just 2. Now we have to use a little trick. So notice that n factorial is n minus 1, n minus 2, n minus 3, all the way down to 1, right? But n minus 2 times n minus 3 all the way down to 1 is just n minus 2 factorial, right? So that means we can rewrite this, and the same goes, by the way, for over here. We just have to go down to n minus 3. So that means that we're going to get 2, sorry, not 2, got rid of that, n minus 1, n minus 2 factorial over n minus 2 factorial x squared is equal to n minus 1, n minus 2, and then n minus 3, but all the way down to 1, so that's just n minus 3 factorial over 3 factorial n minus 3 factorial, x cubed plus nx. Gonna have to go to the next page here. So you'll notice that we can cancel out these factorials because they're both the numerator and the denominator. That means that we're going to get n of n minus 1 x squared equals n minus 1, n minus 2 x cubed plus nx. Right, this is over 3 factorial, which is 6. So let's multiply everything by 6. So that means 6x squared of n squared minus n, I'm just expanding that bracket, is n of n minus 1, n minus 2, x cubed plus 6 and x. So that's going to be, let's just leave that, so 6x squared of n squared minus n equals, what I'd like to do with these is multiply these together. So that's n squared minus 3n plus 2 x cubed plus 6 n x. Let's just have a look if we're moving in the right direction. I think so, except we have these x's. Oh, my bad, I'm terribly sorry. It says the coefficients. The coefficients are equal, so actually we can just get rid of all the x's. Terribly sorry, I was wondering why there are so many x's floating around. So actually we can just forget about the x's. I should have done that from the beginning. So that means 6n squared minus 6n is equal to n cubed minus 3n squared plus 2n plus 6n. Okay, this is looking a bit better. So now I'm just going to move all of these terms to this side. So n cubed minus 6n squared from the left hand side and the minus 3, so that's minus 9n squared. And then here we've got 8n, but then add plus 14n. Because we've got 8 on this side, on the right hand side, and then adding 6n to both sides, we get 14. That's equal to 0. Let's just double check. That's exactly what we need. So that means that we've shown the part I of b to be true. Terribly sorry about that x thing mix up. I forgot that it's the coefficients, but it's fine. You can just get rid of them because we didn't actually manipulate them. So now, double I just asks us to solve the value of n. So that means 0 is equal to n cubed minus 9n squared plus 14n. That's equal to n. We can factor out an n here, which means that we end up with a quadratic, which we like, because we know how to factor those. And you'll notice that that's the same as n minus 7, n minus 2, right? Because minus 7 minus 2 is 14. You add them together, you get minus 9. And that's equal to 0. So that means n equals 0, n equals 7, or n equals 2. But remember, all the way at the beginning, what did I highlight? I said, all the way up here, the n is greater than or equal to 3. So which one of these works, or which one of these is within those bounds? This one over here. So that means we get n equals 7. That's our final answer. So don't write these are incorrect. These are not correct. They're correct from the quadratic, but the beginning of the question tells us n has to be greater than 3. So I hope you guys enjoyed this question. I actually find it really nice. I like how they've brought different parts of the syllabus together with the sequences and the binomials, and you have to know these coefficients pretty well. Hopefully this was clear enough. It was a bit quick, bit of a longer video than usual, but still a bit quick. And I'm sorry about the mess up with the x's. I've completely forgot that it's the coefficients, but sometimes that happens and you can just think, oh, I can just get rid of the x because I'm only interested in the coefficients. So hopefully this was helpful. If I'll be making more of these videos in the future as well, so there will be more coming out. If you guys want more lessons based around the actual concepts and understanding the topics, rather than just exam prep and exam practice, feel free to head over to Tutoring. You can grab a tutor there. You can set up how frequently you want your lessons, how long you want them to be. It's very flexible. You can tell your tutor what you need help with. So yeah, if you guys need help with prep or just want to revise, feel confident for your exams whenever they're going to be, then feel free to head over to there. I'll be making more of these videos, and yeah, have a great day.